Welcome to part 4 of calculations regarding capsule dosage form. In this video, we are going to look at a very unique request, making capsules for a drug that is less than the least weighable quantity. Don't be fearful of the concept. The triturate is normally less than 50% if it's the least weighable quantity that we're asking for. And so for pharmaceutical calculations, we normally treat the triturate as though it was pure starch. You're going to see how efficient this calculation can be. And let's get started. Foundation. This is a refresher to video number 1, where we introduce the definition of terms and the key concepts. If you are using a triturate that is less than 50% in concentration, that means the drug will occupy a very small portion in the aliquot. What we are saying is that you will treat the aliquot as though it was the diluent. Very simple. Let's think about it. If your prescription needs 30 milligrams of drug and the least weighable is 120 milligrams, that means 90 milligrams of the triturate aliquot is the diluent. And so the bulkiness, the space that it will occupy in the capsule is as though it was pure diluent. So don't overthink it. So whenever you're doing calculations for capsules with triturate that are less than 50% in weight and concentration, the fill capacity or the density of the active ingredient is not necessary because the dominant ingredient is the diluent. And so pretty much you're going to find that for calculating the diluent needed to make our capsules, you don't need a fill capacity data for the drug, the active ingredient, any at all. When you come to us in year 2, right? When you come to us in year 2, we normally give you triturates, which includes a 1-in-2 dilution, where the drug has its own identity. The drug is in equal portion or even the more dominant ingredient in the aliquot. So think about it, right? Then you would need the fill capacity for the active ingredient as well as for the diluent. So this calculation, we're going to look at a prescription for piroxicam, a painkiller that is only 10 milligram as a dose and the meter is 3. So we normally make 40% extra. We know that this is going to be 5 capsules. The least weighable is 120 milligram for a class A prescription balance, which is the sensitivity requirement is 6 milligram and the allowable error is 5%. So we're going to use a size 1 shell. We have the fill capacity for the starch. We have the fill capacity for the piroxicam, but you're going to see that we really don't need it. And then the weight of the shell. Meter 3 capsules, the fill capacity for the piroxicam really will not be used any at all, as said before. So we need 50 milligrams. We have made a decision. 5 capsules will be calculated for, and we're going to package 3. So here we need 50 milligrams of drug, and it is below the least weighable. So guess what? We are going to make a triturate. Let us review quickly, and this is a duplication of the recording for slide 1. The recording number 1, I'm just repeating the topic here. Triturate is a dilution made with an inert substance. The aliquot is a portion which is carrying the drug that you need. Trituration, again, if you watch or read some pharmaceutics references, is also made reference to whenever you're mixing powders. So rules again, if you need less than 10 milligram of a drug and the least weighable is 120 milligram, a serial dilution has to be made. If you need, say, 10 milligrams and less than half of the least weighable, you can use the aliquot method or the LWQ method for finding out the aliquot that you need. If the drug that you need is half of the LWQ and greater, then a 1-in-2 dilution is normally used. Please review those topics. So let's look. There are some facts. The least weighable is 120 milligram. We need 50 milligrams of piroxicam to make our 5 capsule. We are going to use the least weighable method to make our triturate, and the ingredient is piroxicam and starch. So let's get started. The first thing you set up is your ratio and proportion. Let my aliquot be 120 milligram. What does that mean? 50 milligram that we need will be carried by 120 milligram of the aliquot. Therefore, I am going to use 120 milligram of piroxicam powder to make my triturate. So when I set up my ratio and proportion, the total triturate is 288 milligrams. It means my diluent is the total mixture minus the total drug to make the triturate, and so I only need 168 milligram of starch. The concentration of my triturate will be the drug used to make the triturate over the total triturate made times 100, which is 41.67%. This is my new formula: piroxicam 120 milligram, starch 168 milligram. I'm going to mix it together, and I'm going to remove an aliquot of 120 milligram. You already established it right here. 50 milligram is in 120. So I'm going to remove 120 milligram, which is carrying the 50 milligrams required to make my 5 capsules. So now that we have solved the triturate, how much starch do I really need to fill the 5 shells? And this is where I'm telling you now that the fill capacity of the piroxicam, I strike through it right here because you really don't need it. What we'll be using is that of the starch alone. So you'd say starch alone to fill the 5 shells is 352 milligram times 5, 1760. So the starch needed will be starch alone minus the starch represented by the aliquot. Remember what I told you? That the dominant ingredient is starch in the triturate because it's so dilute, the drug is so small in it, that you just subtract. Straight subtraction. So starch alone minus the 120 milligram aliquot gives you 1640 milligram, and that's it. It really doesn't get more complicated than this. And so the starch needed is 1640, and the triturate is 120 milligrams. Sorry. When you add these two and divide by 5, the powder per capsule will be 352 milligram, and the gross weight, which is the weight of the capsule plus the shell, will be 352 milligram plus the shell weight, which is right here, 72 milligrams. So here it is. We're finished. Whenever you are making capsules with a triturate which is less than 50% weight in weight, the triturate is treated as though it is the diluent because the dominant ingredient is the diluent. And believe it or not, that's it. That's really it for you making capsules with a triturate. So please remember, if however the triturate was 50% or greater than 50%, then you'd have to use the fill capacity for the drug being carried by the aliquot. Whatever the aliquot is, if the aliquot is 120 milligram, and it's a 50% triturate where 60 milligram is the drug, 60 is the starch, then you find the starch equivalent for the 60 milligram component because the drug has its own identity. That's what we'd say. Triturates which are 50% and more, the drug has its own bulkiness, shape, and identity, and so you would use the fill capacity information to find out the starch equivalent for the drug being carried by the aliquot. Right? You account for the diluent, which is also in the aliquot, and so you're subtracting those two things from the starch alone. Feel free to just change the number of this prescription, the dosage, to create multiple scenarios until you are comfortable with what the principle is. Again, if the triturate is less than 50%, the aliquot is treated as though it is the diluent because the diluent is a dominant ingredient, and so the density of that powder or the fill capacity of that powder really is not necessary for any calculation. And that brings us to the end of this recording, a very short video. Replay it until you have an appreciation for the content. Thank you for listening.